folks, we are going to talk a little bit about G's or G-forces. Now, one of the things that is very confusing, and again, it's that darn English language that causes trouble, is that when we refer to G's, we are referring to a measurement of acceleration. Acceleration, as you know, are caused by net or unbalanced forces, but people tend to use the term G-forces when they're really experiencing acceleration. 1 G is equivalent to 1 acceleration of gravity, which is 9.80 meters per second squared. And if you want to calculate G's, it's the acceleration something is experiencing divided by 9.8. And since both are in meters per second squared, you end up with G's actually being a unitless number because it is a ratio. I want to spend a little time talking about the difference between positive G's and negative G's. Positive G's are situations where you feel pushed into your seat. When do you experience these? The bottoms of hills, when an airplane takes off. And if we put a bathroom scale under your body, you would actually weigh more. There would be an increased force, and that's that excessive net force that causes the acceleration. So when something like this group of roller coaster riders are coming down to the bottom of the track, what happens is their inertia at the bottom of the track wants them to keep going in a straight line. Well, the track exerts a centripetal force on them, and that keeps them going in a circular motion. But their bodies want to keep going in a straight line because of inertia. And it's that push that if we put a bathroom scale right under your little body, when you were at the bottom of this hill, you would actually weigh more because it was a combination of the force of gravity you were going to feel plus the normal force of the track pushing you into that circle. Those are positive G's. Now, typical person can tolerate 5 G's for an instant. We're talking fractions of a second. Most roller coaster rides are going to have G's in the realm of positive 2, some of them positive 3 G's that you're going to experience maximum. Why? They don't want, on roller coasters, they don't want small people passing out or old grannies passing out. It's not good for business. So they don't experience an awful lot of G's. The reason why people can pass out is because if you're in a situation where you're experiencing positive G's, the blood in your body is flowing. And if the inertia is pulling you this way, the blood in your body is going to have a tendency to go that way as well. So it's going to go downhill. It's going to come out of your head. And if the blood rushes out of your head, you have a tendency to pass out or faint. Well, you don't want that in a roller coaster ride. And they do a lot of training with fighter pilots for things like this because some of these aircraft cost billions of dollars, and these pilots are very valuable human beings, so they want to make sure that the pilots can breathe through these excessive G's. Now, one of the things I think is fascinating is that if you ever look at a space launch, the actual astronauts are seated like this. And the reason they launch in this sort of an orientation is because of the fact that they're going to feel an acceleration from their hiney. Now, their back, their butts, their thighs, these are big muscle groups. So they want to push on the actual humans on their strongest parts of their body. Where's their blood going to flow? Their blood's going to flow into their brain. It's not out of their brain. And space shuttle launches are going to have a maximum also of right around 3 G's. Nothing too extreme. If you like watching aerobatic pilots and things like that, they can sometimes go up to 9 G's. Sometimes they're going to go for an instant over 10 G's. And they train excessively to be very, very strong and be able to, with biofeedback, keep the blood in their brain so they don't pass out in their aircraft. Now, negative G's are when you feel like you're being pulled out of your seat. If you drive really, really quick over a railroad track or something like that, you're going to go wee and you're going to catch a little air. That's a negative G. Now, in a situation like this, Humans can tolerate very, very few negative G's, because here's what happens. As you're going towards the crest of this hill, where's your blood going to flow? Your blood's going to flow upward. What's the challenge with that? Well, it's going to, due to these acceleration, you're going to have much higher blood pressure in your head. Well, if you have too high a blood pressure in your brain, what's going to happen? You possibly could have a stroke or a rupture of blood vessels in the brain. So human beings cannot handle very many negative G's. A G suit, training, things like that are not going to help. The only thing that can help a little bit is being cardiovascularly very, very strong. This is also if you catch a little air going over a hill and you feel a little tiny fraction of weightlessness. That can be a negative G. Now, I'm going to follow this video with a collection of YouTube videos I'd like to have you watch that are on G forces, showing humans breathing through these various Gs. And then one of them is going to be Colonel John Strapp. Back in the 1940s and 50s, this gentleman, doing some safety tests, experienced well over 46 Gs and pretty phenomenal stuff. All right, have a good one, and we'll see you later.